Greetings! Today I'm gonna do a retro teardown. What I've got here is Palm Tungsten, and this used to be the awesomest thing you can possibly own, especially for a businessman. This was a PDA, portable digital assistant, and Palm was one of the best, if not the best, in that field, in making those. And yeah, those things were quite expensive and quite popular in certain parts of the world. So yeah, let's have a look what sort of old technology is in there. And yeah, we'll be taking a closer look at the insides. It feels metal, but it's not. It's actually a very heavily metallized plastic. It feels really nice. Okay, to begin with, we've got 4 Torx screws in each corner, so let's take those out. And now should be able to wedge the back off of it. There we go. By the way, I've tried charging it and it's not taking any charge, so it is dead as far as I'm concerned. And there we go, we are inside, and I can tell you why it wasn't charging. Look at this battery, it's blown up like a balloon, but okay. On the outside, it's very heavily metallized on both on the inside and the outside, and here we have a speaker wedged into the casing, and here are the insides. So let's maybe remove the battery. I think that's held on a glue. What was the battery anyways? Samsung. Oh, so Samsung has got some historical problems with batteries. Oops, this is falling apart, and we've got a memory card in here. There we go, the glue let go. Let's cut that off. We'll have a look on the inside of this battery later on, but now let's focus on this. So let's get a little bit closer, and we are in the top left corner of the device, looking at it from the back, and you can see the metal threaded inset over here. That's for the back case, really nice. It's not self-tapping screws going into plastic. A couple of transistors, couple of 6-volt surface mount caps, a few more miscellaneous O102 components, really tiny, impossible to solder this by hand. Headphone jack, and a chip which seems to be, if I just angled it a little bit better, TPA751, which is most definitely headphone audio, an audio amp, and that's what's putting out the audio out. And also those contacts over here, this is what mates up with the speaker over here. Will it focus on this? There you go. So those connectors mate up with the little circle on the PCB, and that's what makes the contact onto the loudspeaker. And further to the right, we've got the SD card slot, or not SD, it used to be called multimedia card, MMC. So MMC card slot with nice little gold contacts, and more tiny surface mount stuff. We've got some 5-pin device over here, whatever that is, PHU1. Okay, and here we have one of the chips, TSC2102, and here under a serial number sticker hides something else, so let's peel that off. Okay, and it's a Winbond W982516BH75L, which is, I've looked that up already, and it's a 4 MB times 4 banks of 16-bit SD RAM. and yeah, that is the memory of the device. Moving on to one of the sides, we've got really tiny resistor packs. Those are just standard resistors packed into 4 bunches of 4, and some capacitors. Further to the side, we've got anonymous parts which look like resistors. It could be something else. And some capacitors, and here we have the main brain, so the Texas Instruments OMAP. And it's a OMAP 311. It's a 2002 vintage Texas Instruments RISC reduced instruction set computer. Really nice processor for the time. Now, interestingly, you can see the gold pins all around the unit. They're very dense. I'm not sure what the pitch of that is, but it's ridiculously small. Looking naked eye on it, I can barely notice that those are separate legs. But even more interestingly, you can see that they don't go all the way around. There are gaps in the top left corner, you can see right now, and in the top right corner there are gaps where there aren't any legs sticking out of the plastic encapsulant. So that's interesting. And another unusual feature, you can see towards in the 2 bottom corners, you can see that the pitch goes from fine to ridiculous for the few pins on at the very end. Moving a little bit further down towards the device, I've changed the orientation, so maybe let's go back to the original upright position. And we've got some more parts, some of the parts that seem like have been not fitted. We've got the watch crystal here, and another small device, micro USB port. No, sorry, this is actually a charging connector, so it's a mini barrel plug connector, and the micro USB is next to it. I'm not sure why did they have to it took 5 volts as an input, so I'm not sure why did they have to put in a separate charger port when they had a micro USB on there. It could have comfortably used that for charging alone, and that would have done it. But yeah, clearly they had a different idea. Here's one of the battery clips that I've cut off. Another small device, an inductor, so clearly this is a power supply section happening over here. And we've got another big chip from AMD this time. Let's rotate it around. And this is a flash memory. That's all that we have on the back. And you can see there is some damage. There's probably some liquid damage happening over here. This is probably a leak from the battery that caused some bad erosion on the PCB. And you can see it somehow found its way underneath the solder mask, so the tracks must be completely destroyed in there. Let's press on with taking this apart. So since we've seen everything on here, so we've got the little flat flex which should pop out like so. We should be able to lift one of the sides up. Like so. And here we have back of board, and if you can see, all of those are test points. There is an absolutely mad amount of test points on here. This would have landed on something what's called bed of nails, and all those test points would have connected to everything as required and basically did a whole bunch of testing, and it could have been even programmed through this. Over here we've got an infrared blaster transceiver, so we've got transmit and receive diodes over here, and yeah, that was used. You could back in the days when computers had an infrared port. You could communicate and synchronize your calendar and appointments and notes with a computer, with a piece of software that you had on your laptop. And yeah, that was amazing. Going deeper into this, what we've got over here is another board, which I think this would be the display driver board and the touchscreen controller. We've got the flat flex, which comes off on a little clip made by Molex, and we have the screen that will come out just like so. So let's have a look at the screen itself. It's you can see this whole unit is nice and compact, only one connector coming through to it from the main processor board. The screen itself is made by Sharp and the model number is LQ030B7DH53. And yeah, I was looking up some data sheets here, and it is possible to find information on this, but it's not very usable, I guess, in this state. And what we have over here, we'll have a closer look in a moment, but briefly, this is probably the backlight connection. If this has a backlight, this drives the LCD itself, and this connector is for the resistive touchscreen. And the touchscreen itself, you can see this quite interesting. It's a sticker that's stuck on top of the screen. So let's try to peel that off, and maybe in a different video we'll try to make a use of it or get it to work. But let's try to peel this off, maybe with just a tiny bit of there you go, it is going. So it is glued all the way on the outside edge. So that comes off quite nicely, actually. Okay, and that is the screen, and let's disconnect this from the tiny connector. Okay, and a few prying attempts later, there we go, we can take off the front bezel, which got stuck to the table because there's residue from the touch screen. And here we have the front of the screen, and as you can see, the touch screen, the screen itself is rectangular. It's 320 by 320 pixels, and here we have 1, 2, 3, 4 quite large pieces of silicon. Those would be the column and row drivers on the LCD itself. So let's see what will it take to take that out of this plastic. And here, and so we've got beautiful mirror. Well, we've got the usual setup. Let's see if we can take all of this out without screwing up the order that it is assembled in. So we've got the usual setup of a few layers of different sort of materials, diffusers and all kinds of things that are meant to give you unique and uniform backlight. And you can see it's making weird and wonderful images on the camera. So we'll get back to that later. And here we have the back of the LCD itself. It's as you can see, it's very nice mirror. here we have an LCD module, and it seems like they had to make this little board. There's no active components on here, but this purely just snakes out all the trucks to all the different places. It's a two-sided job, so it gets little wires through a matrix of different connectors, and it's basically a labyrinth of connections going into here, and around we've got the trucks that are going to the row and column drivers. So this LCD, I think in its current state, it will be interesting to have a look at it under a microscope. Maybe I'll maybe keep accumulating interesting stuff for a microscope, and one day I'll make another episode with different things close up. It will be nice to have a look under a microscope through this. We'll be able to see a lot more detail than through the polarizer film, which is kind of matte and obscures quite a lot of stuff. And the pixels on this are quite big by today's standards, so it will be very visible on what's happening inside. So yeah, I'll save that for another video. And we've got this board which should come out somehow. It's held in with just little clips. And there we go, it's a sharp driver board. So here is the driver board from the LCD. We've got a inductor, a really small trimmer pot, VR1, miscellaneous 6-pin device, a couple of capacitors, another 5-pin device, which is marked R5, okay, caps, sharp IC in a square package, 3E312, another square, this is a BGA package, a few smaller components, a connector, another connector, the one that goes to the main board, the LCD screen connector, and another sharp bespoke part, and another component which I'm not even going to bother to look up the data sheets. Okay, let's have a look inside this battery. I know you're not supposed to puncture and cut those open, but yeah, who's gonna stop me? Anyways, it's a dead battery, so there isn't, or the risk for this to go bad is minimal. But anyways, we've got a protection circuitry for the PCB. So okay, what's inside this battery? I know everyone is scared of those lithium batteries, but I'm feeling brave today, so do not puncture. If this was fully charged, that would definitely end up really badly. But because it's a dead cell, it's yeah, it's very unlikely to go horribly wrong. And the outside shell is just a aluminium or it's aluminium and plastic sort of pocket. And on the inside we've got a roll of film, a couple of films actually. So we've got this shiny stuff, then we've got a plastic membrane It's I think this is semi-permeable membrane, I think it's called, and we've got a layer of carbon maybe and lithium. There should be lithium coating somewhere on here. So this apparently lets through some of the stuff, and I think the copper is lithium coated, or maybe this. I'm not too sure. It's still wet-ish over here, and it very quickly evaporates. So there is a little bit of solvent. Smells like spirit. Yeah, it definitely smells like spirit, and I'm sure you can see as soon as I open it, it all evaporates almost instantly. I'm not sure whether it's wise to keep breathing this in, but okay. There you can see all this actually all peels off, and it's coming off of the copper film. I think I've gone too far. I'm just making a mess now. So this is really strong. Yeah, there you go. I've made a mess out of it, but I hope you enjoyed this little teardown. This is the aftermath. So hope you enjoyed it. Give me a like if you enjoyed this video, and subscribe for more random stuff, electronics related, at least most of the time. As far as this one, that's it. So thanks again, and for the time being, take care.